Hello Year 11, we're going to do an experiment today with these two chemicals here. This is sodium thiosulfate and hydrochloric acid. And we're going to change one of the variables. The variable that we're going to change today is the temperature of the two different liquids that we're going to use. So, how will we know when a reaction has happened? We're not measuring volume of gas given off this time. You will see what we're going to do. I'm going to take a glass measuring cylinder and I'm going to measure out 20 mils of sodium thiosulfate. Don't worry about learning the spelling as long as you recognise the chemical, sodium thiosulfate. And I'm using a glass measuring cylinder so that I can tell it's going to be different from the hydrochloric acid, because if we get those mixed up, they'll start reacting in the measuring cylinder before the reaction starts, and you'll see why that might be a problem in just a moment. So then we're going to take our plastic measuring cylinder and I'm going to measure out, this time, 20 mils of hydrochloric acid. So there's 20 mils in each of those measuring cylinders. I'm going to take the conical flask, which is shaped like a cone, which is where it gets its name from. I'm going to put on a piece of paper with a cross on. Why is the cross there? It will all become clear in just one moment. I'm adding my 20 centimetre cubed of sodium thiosulfate. I've got my hydrochloric acid here. As soon as the hydrochloric acid enters the conical flask, I'm going to press start. You're going to see what happens in just 1 second. Now, the hydrochloric acid and the sodium thiosulfate are going to start reacting. When they react, they produce a solid particle, which is a yellow solid particle, and it's going to make, you're just about to see that start to go cloudy. And eventually, if we just bring the, you can still see the cross, but eventually it's going to get so cloudy that we can't see the cross, and then we're going to press stop. Okay, let's have a look. We've got 26 seconds. So that took 26 seconds for the reaction to produce a solid that will make the cross disappear. Now we're going to repeat this experiment, but this time we're going to use sodium thiosulfate and hydrochloric acid at different temperatures. But before we do that, we're going to need a results table. So when I draw a results table, I want to have two columns. And the two columns are going to be for the variable that we change in the first column, and the second column is the variable that we are going to measure. So the variable that we are changing is our temperature. So in the first column, I'm going to put temperature, and then in brackets, I'm going to put the units that we measure the temperature in, which is degrees Celsius. In the second column, I'm going to write down what we're measuring, which is the time taken for the cross to disappear. And we're measuring that in seconds, so bracket with a small s. So room temperature was 20 degrees Celsius, and it took 26 seconds for the cross to disappear. I'm going to repeat that at 30 degrees Celsius, 40 degrees Celsius, and 50 degrees Celsius, and then we're going to have a look at the time it's taken for the cross to disappear. Okay, so how do we get our hydrochloric acid and our sodium thiosulfate at different temperatures? We use this piece of equipment here, which has got water in here, and then there's a little heating element here, and then we can set the temperature, and it's called a water bath. So this is 30 degrees Celsius, 40 degrees Celsius, and 50 degrees Celsius. So I'm going to take out my sodium thiosulfate and my hydrochloric acid. I'm going to remove my room temperature so I don't get them mixed up. And this is and I have a new conical flask ready here now, and repeat the experiment in the exact same way. So in the glass measuring cylinder, 20 degrees Celsius, 30 degrees Celsius and 20 centimetre cubed. This is my acid, 20 20 centimetre cubed. A new conical flask. Sodium thiosulfate in first. I'm going to reset my time. And I'm going to add 3, 2, 1. You can see it's starting to go cloudy. And as soon as we cannot see the cross anymore, I'm going to press stop on the timer. And now. Okay, let's have a look. The time is 19 seconds. So I'm going to record that on my table. We've got at 20 degrees Celsius, it took 26 seconds for the cross to disappear. At 30 degrees Celsius, it took 19 seconds to disappear. And we're going to repeat the whole experiment again. This time, we're going to use sodium thiosulfate and acid at 40 degrees Celsius, and I need a new conical flask. Again, 20 centimetre cubed. Oh, that's quite warm. Okay, here's my sodium thiosulfate in my conical flask. And ready, 3, 2, 1. Nearly there, and stop. So that took, let's have a look, that took 12 seconds. So at 40 degrees Celsius, it took 12 seconds for the cross to disappear. Our final temperature, 50 degrees Celsius. Take our lovely warm sodium thiosulfate. Oh, make sure I don't get that round the wrong way. Which has now been warmed to a very warm 50 degrees Celsius. You're lucky you're doing this on video. In person, it smells like sulfur, which is a smell of rotten eggs. So we suffer for you. There we go. New conical flask. Sodium thiosulfate, acid, 3, 2, 1. Stop. And that only took 7 seconds. So at 50 degrees Celsius, it took 7 seconds for the cross to disappear. And those are our results to show how temperature affects the rate of reaction.